So we're continuing with Math 125 gateway questions, this time number 46 out of the series 41 to 50. We're going to use chain rule, product and quotient rule, sum and difference rule, and power rule in here. So the function is h of s equal to square root of numerator s squared plus s minus 2, denominator s plus 2. So what I see is coming from outside. First of all, I like to rewrite this as the square root as power 1/2. So what I see is a general power rule, or I see the outside function as a power function. So when I'm taking the derivative of this with respect to s, first I use the power rule. Okay, power rule is the power comes down, to power 1 less, inside is unchanged. Then inside is a chain rule. So the next step to do is to do the chain rule, and then I see a chain rule because it's the power, a composition of a power function and something inside. And inside it's not just s. So I have to take the derivative of inside. So I have to take the derivative of s squared plus s minus 2 divided by s plus 2 ds of this one. So this part's still there. The next step is this derivative. This derivative is the first thing that I see is the fraction line. Therefore, I have to use the quotient rule. Quotient rule tells me a derivative of top times the bottom, 2s plus 1 times the bottom, times and minus top times the derivative of bottom in parentheses. And derivative of bottom is 1 divided by s plus 2 to power 2. So looking at this, I can enter this entire thing in my gateway exam and it would be correct. For some specific reason, though, for this one, I want to simplify this so you can see how this can change. So if I simplify this, I get 1/2 and the numerator is 2s times s, 2s squared, 2s times 2, 4s, plus s times 1, 5s, plus 2, minus s squared minus s plus 2, and then simplifying that gives me s squared plus 4s plus 4. Okay. At this point, even though I could have entered this and just forget about the entire problem, at this point I'm suspecting things. Look at the numerator up here. The numerator is actually s plus 2 to power 2. It's a binomial expansion. And then I start thinking about this a little further. Can s plus 2 be a factor of s squared plus s minus 2? And it turns out yes. S squared plus s minus 2 actually factors into s plus 2 and s minus 1. And so I could have simplified this and took the derivative. And this is the only difference is if you're simplifying a function and taking the derivative, there would be a domain issue. But the gateway exam accepts. We accept the most restricted domain for the entire derivative. And therefore, you can just take the derivative of simplified form of that and then and put that answer inside your gateway exam. So this is okay. This is the part that I suspect there is other ways of doing this. And then the last part is I'm going to erase the board and give you an alternative way of when we simplify the function and then we take the derivative of it. So continuing with question number 46 out of the gateway questions for Math 125, we discussed that the first method will give us this value after simplification. What value do we get when we simplify the numerator and denominator, then take the derivative? So let's try to take the derivative of simplified form. Again, on the side, s squared plus s minus 2 is equal to s plus 2 times s minus 1. So in here I replace. Here again, I'm assuming the domain doesn't change. So we're assuming that s is never going to be equal to negative 2. And then I simplify. So this entire thing becomes s minus 1 to power 1/2. Now let's take the derivative of h with respect to s when s is not equal to negative 2. Well, domain is more restricted overall, but when you simplify, this would go away by reinstating that, makes it all work. And so dh ds is going to be, the outside function is the power function, so it's 1/2. Then inside function to power 1 less, 1/2 minus 1 is negative 1/2. Derivative of inside, derivative of s minus 1, which is 1. So the entire thing becomes this answer. Was that the same thing as this with the domain restriction that we give? Let's try. So this would be, I am simplifying this to 1/2. Simplifying the inside, I get s minus 1 to the power negative 1/2. And these two simplify, so I get the same answer. This is easier to deal with since our systems accepts the more restricted domain, and hence take this away, and this is your final answer that you can enter.